This was supposed to be a nice simple video about vehicle stability, but at some point, about a week into its production, it developed the requirement to include a cartoon bear, and it's never quite recovered since. Let's just try and make the best of it. To understand vehicle stability, it's first necessary to understand the concept of centre of gravity. Centre of gravity is the term that is used for the point in the vehicle at which all of the mass of the vehicle acts. Now, here we have a very simple model, which you will recognise as being a seesaw. And I've got two heavy masses sitting on the ends of my seesaw, and the two masses are exactly the same mass as one another. And they are exactly the same distance from the fulcrum, from the hinge of the seesaw, as one another. So they perfectly balance out the seesaw. The position of the centre of gravity is indicated by that little black and white symbol, and that's the standard symbol that always gets used for indicating centre of gravity position. You'll notice that the centre of gravity is not inside either of the boxes, or indeed inside the seesaw. The centre of gravity is kind of floating about in space. But for that structure of plank and two boxes, its centre of gravity is actually sitting in fresh air, not inside any of the structure. And that can be the case with vehicles. You can end up with the centre of gravity potentially sitting in the fresh air inside the cabin, or even inside the load bed or something like that. So it doesn't have to be where the mass is. So the centre of gravity doesn't indicate where the mass is, it indicates where the mass is acting. Now if I move my boxes into the centre of the seesaw, provided I move them at the same speed, then the seesaw stays balanced. And as far as the centre of gravity is concerned, nothing changes. The position of the centre of gravity hasn't changed. What has changed, though, is a thing called the moment of inertia. So the moment of inertia is the property of a body that dictates how hard it is to make it change direction, or how hard it is to make it rotate. So with my two boxes in the centre of the seesaw, it's relatively easy to make the seesaw seesaw. If the boxes are at the ends of the seesaw, then it's very much harder. So from a static stability point of view, we're only really interested in the position of the centre of gravity. But when we start thinking about dynamic stability and how manoeuvrable or stable a vehicle is, then the moment of inertia, the distribution of the masses within the vehicle, also becomes important. But that's probably a story for another video. If a vehicle is going around a corner, the mass of the vehicle acts directly down from the centre of gravity and effectively points straight down towards the centre of the Earth. So that arrow is indicating the mass of the vehicle acting downwards, creating the weight of the vehicle, because weight and mass are not the same thing. Mass is an intrinsic property of the materials from which the vehicle is made, whereas weight is the interaction between mass and gravity. As we're going around the corner, the vehicle obviously has to develop some force to change direction, and we usually call that force centripetal force. So that's the force to turn the vehicle towards the centre of the circle, to make it describe a circle. And there is an equal and opposite force, which we call centrifugal force, which pushes the vehicle outwards towards the outside of the circle. That force, and in fact all forces that act on the mass of the vehicle, act through the centre of gravity. And you can see that as the vehicle speeds up, then the amount of centrifugal force that's developing increases. It is of course possible for a vehicle to become unstable simply from trying to turn too tightly. So if you apply a very hard steering force and try and describe a very tight circle, particularly if you're travelling at high speed, the vehicle can overturn even on a flat road. Generally, certainly vehicles on tarmac tend to run out of traction before they run out of stability. So they'll usually skid rather than roll over. But not all the time, and it is possible to roll vehicles over simply because of the manoeuvre that they try to perform. For off-road vehicles, of course, we have the added problem that the terrain itself is not flat. So potentially we could have a vehicle that was stationary, not moving at all, but because it was sitting on a steep side slope, the vehicle could fall over. So the vehicle could become unstable even while it was stationary. You can imagine the situation where you park it on a side slope which is at the very limit of what the vehicle is able to maintain stability at, and then you slam the door and that force is enough to make the vehicle fall over. When we're testing vehicles, testing their stability, we normally do that on a thing called a tilt table. So the idea of a tilt table is that's a platform that you drive the vehicle onto, and you can tilt the platform up progressively until the vehicle becomes unstable. And normally we do that up to the point where the uphill wheels start to lift away from the platform. And if you think about what's happening, as the vehicle starts to become unstable, weight is transferring from the uphill wheels to the downhill wheels. So as the slope gets steeper and steeper, the uphill wheels are taking less and less load and the downhill wheels are taking more and more load, up to the point where one of the uphill wheels is taking no load at all. And normally when we're testing, we would stop at that point. The purpose of doing a tilt table test is usually not because we want to understand the side slope that the vehicle could be stable on, although that is interesting. We normally use it as a way of establishing the height of the centre of gravity. So you can see in this illustration that the arrow pointing straight down from the centre of gravity always points straight down towards the centre of the Earth. So as the tilt table goes up, it carries on pointing straight down. Eventually, that arrow will get to the point where it's pointing outside of the wheel track of the vehicle. So when it gets to the point where it's gone outside the edge of the downhill tyre, at that point the vehicle will become unstable. So you can see that the wheel track of the vehicle, how far apart the wheels are, is an important factor in maintaining the stability of the vehicle. Normally track is measured to the centre of the tyres, so you can also see that the overall width of the tyres is important. So you could potentially have two vehicles with the same track as one another, but the one with wider tyres would be more stable because there would be more tyre sticking out from the centre. If we raise the centre of gravity, so in this case we've got a big roof rack and we've loaded it up with lots of heavy things, the centre of gravity has got higher, and you can see that as the vehicle starts to tilt, it doesn't have to get to such an acute angle before the arrow pointing straight down towards the centre of the Earth gets outside of the overall width of the axle and becomes unstable. This is the reason why having a heavy load on the roof or just a vehicle that inherently has a high centre of gravity will make that vehicle unstable. As well as the height of the centre of gravity, the lateral position of the centre of gravity is also important. So if the lateral position of the centre of gravity is not in the centre of the vehicle, as it very often isn't, you'll find that the vehicle will be more stable one way than the other. So depending on which way you position it on the side slope, it will either be more stable or less stable. Longitudinal stability is also important. So longitudinal stability tends to be less of an issue. We tend to see fewer vehicles that fall over longitudinally. The vehicles we do see fall over longitudinally tend to be things like ATVs that have a very short wheelbase and quite a high centre of gravity, because obviously a lot of the mass of an ATV is in the body of the rider. So it's not unusual to see ATVs either pull a terminal wheelie or even fall over forwards sometimes. But the things that are affecting stability then longitudinally are the wheelbase of the vehicle and the height of that centre of gravity again. But there are also some other factors at play here. So as you accelerate the vehicle, that acceleration force will act through the centre of gravity. and that will either make the vehicle pitch up or down. So if you think about the way you pull a wheelie on a motorcycle, the first step is that you make it go faster, you accelerate, and that causes a force, an acceleration force, to act through the centre of gravity, which starts the vehicle rotating around its rear contact patch. And the other thing that happens on a motorcycle particularly, because they're rear wheel drive, is you get a torque reaction. So as you put a torque into the rear wheel, it effectively tries to rotate the vehicle around the back wheel. On a motorcycle, that's enough to be able to lift the body of the vehicle up and pull a wheelie. You don't usually see that in four-wheel vehicles, but certainly you need to consider the effect of torque and how it is acting in the way that will affect the stability of the vehicle. You can also have the same effect with braking. So if you're going down a very steep slope and then you apply the brakes, that will also create an acceleration force which can start to rotate the vehicle around the contact patch and make the vehicle unstable. So what are the take-home messages here? Well, first of all, vehicle stability is all about the relationship between centre of gravity position, in particular centre of gravity height, and the size of the footprint of the vehicle, so the wheelbase and the wheel track. And you can manipulate the stability of the vehicle either by increasing the size of its footprint or by moving the position of the centre of gravity, particularly lowering it. So that about wraps it up for this one. I hope you enjoyed the video. Don't forget to like and subscribe for more off-road vehicle engineering content. Thanks for watching.